organic analysis, how to oxidize alcohols using acidified potassium dichromate. Add 10 drops of alcohol to 2 centimeters cube acidified potassium dichromate solution in a test tube. Warm mixture gently in a hot water bath, and then watch for colour change. Say the colour change from primary alcohol, say the colour change for secondary alcohol. So colour change for primary alcohol, orange solution slowly turns green as an aldehyde forms, whereas secondary is just for ketone. So orange solution slowly turns green as aldehyde forms, orange solution slowly turns green as a ketone forms. Why does the colour change happen for primary alcohol, secondary alcohols? Because the orange dichromate 6 ion, Cr2O72 minus, is being reduced to the green chromium 3 plus ion, Cr3 plus. Describe how to distinguish between the same result of primary and secondary alcohols. This is really interesting. What you need to do then is add excess alcohol to 2 centimeters cube acidified potassium dichromate in a round bottom flask. Gently heat the flask, and what you'll notice is the alcohol will be oxidized and product distilled, so you can collect it off immediately. Describe how to use Fehling/Benedict solution to distinguish between aldehydes and ketones. Add 10 drops of add 2 centimeters cube of Fehling/Benedict solution to a test tube. Add 5 drops of aldehyde/ketone to a test tube. Place in hot water bath and warm. If it's an aldehyde, blue solution will give a brick red precipitate. If it's ketone, nothing happens. The original color of Fehling/Benedict in a test tube, clear blue solution. Describe how to make tolerance region. Put 2 centimeters cube of 0.10 mole per minus cube of silver nitrate solution in a test tube. Add few drops of dilute sodium hydroxide, and you should observe a light brown precipitate should form. Add drops of dilute ammonia solution until brown precipitate dissolves completely. Say how to use tolerance region to distinguish between aldehyde/ketone. Place test tube in a hot water bath. Add 10 drops of aldehyde/ketone. Aldehyde silver mirror forms on walls of test tube. Ketone, nothing happens. Why did you get silver mirror with tolerance region? Because the aldehyde reduces the Ag plus ions to Ag atoms. And why must test tube be heated in water bath rather than flame? Aldehydes and ketones are flammable. Aldehyde reduces Ag plus ions to silver atoms. Aldehydes and ketones are flammable. Describe test for alkenes with bromine water. Add 2 centimeters cube of solution you want to test tube. Add 2 centimeters cube of bromine water to test tube. Shake the test tube. Alkene. Add 2 centimeters cube of solution in the test tube. Add 2 centimeters cube of bromine water to test tube. Shake the test tube. Alkene solution decolorizes. Not alkene, nothing happens. Describe test for carboxylic acid. Add 2 centimeters cube of solution you want to a test tube. Add 1 small spatula solid sodium carbonate. If the solution begins to fizz, bubble the gas through a lime water in second test tube. Solution begins to fizz, bubble the gas through lime water in second test tube. Solution, what happens if solution carboxylic acid? Solution will fizz, CO2 gas produced turns the lime water cloudy. A key thing about carboxylic acid test though is that this test will give a positive result with any acid, so therefore we can only use it to distinguish organic compounds when you know for sure one of them is a carboxylic acid. What does a molecular ion produce? M plus produces a molecular ion peak on a mass spectrum of the compound. And say a key fact about any compound. A key fact about any compound is that the mass to charge value of the molecular ion peak is the same as the molecular mass of the compound. Define high resolution mass spectrometers. Mass spectrometers that can measure atomic and molecular masses to several decimal places, and the use of this, well, they're useful when identifying compounds that appear to have the same MR when rounded to the nearest whole number. What do peaks show you? Peaks show you where radiation is being absorbed, and peaks on infrared spectra point downwards. It's just nice to have this, knowledge. What happens in infrared spectroscopy? Infrared spectroscopy, a beam of radiation, infrared radiation, is passed through a sample of a chemical. And how is infrared radiation absorbed? By covalent bonds in molecules, hence increasing their vibrational energy. A key fact about bonds in different places in different molecule: bonds in different places have different bonds in different places in the molecule absorb different frequencies. Bonds in different places in the molecule absorb different frequencies. Define fingerprint region. The region between 500 centimeters to power minus 1 and 1500 centimeters to power minus 1, and it is unique. The fingerprint region, I repeat, is unique to a particular compound. The region between 500 centimeters to power minus 1 and 1500 centimeters to power minus 1 is unique to a particular compound. What do impurities produce? Impurities produce extra peaks in the fingerprint region.